Hello friends, welcome to follow up. In this video, we're going to look at problem 2682. Find the losers of the circular game. Here we're going to share or explain a solution based on modulo n operation and the use of dictionary. So the use of dictionary is for fast retrieval of information. So we have n friends sitting in a circle clockwise. And the rule of the game are as follows. So the first friend receives the ball, and after that, first friend passes it to the friends who is key steps away from them in the clockwise direction. So after that, the friend who receives the ball should pass it to the friend who is 2 times key steps away from them in the clockwise direction. So after that, the friend who received the ball should pass it to the friend who is 3 times key steps away from them in the clockwise direction, and so on and so forth. So in other words, on the ith turn, the friend holding the ball should pass it to the friend who is I times key steps away from them in the clockwise direction. So the game is finished when some of the friends receives the ball for the second time. So this is the stop condition for the game. So the losers of the game are friends who didn't receive the ball in the entire game. So this is the definition of losers for this game. So here, given the number of friends n and an integer key, so we want to find the losers for this game, and we return them in an ascending order. So here are 2 examples. In the first example, so the return is 4 and 5. You can simulate this procedure and to get this list output. And in the second example, so the output is 2, 3, 4. That's the 2 examples. So here the constraints are the following. First, k is greater than or equal to 1, less than or equal to n, and n is bounded above by 50. So this is the main problem statement. So here in this problem, what I'm going to do is to actually this problem can be solved using some deeper mathematical insight, but here we want to share the sorting process. So here what I'm going to do is I'm going to use modulo operation. Modulo here we are going to modulo n, right? And also I'm going to use dictionary for the fast retrieval of information. So because of the circular nature, so we know that, so once we are at, so for example n, then move to next, so we're going to see n plus 1 will be regarded as a 1, right? So another thing I want to expose is that, so we need to pay attention to the treatment of the indexing. So here the friends are sitting in a circle and numbered from 1 to n, right? So 1 indexing. So but if we want to use modulo n, so the remainder will be in 0, from 0 up to n minus 1. So we need to align these 2 conventions. So with that said, I guess we can directly go to the coding, and in between we're going to explain the logic and explain the code line by line. So first, I'm going to initialize a dictionary. So the dictionary will encode information like this for I in range n. So here I'm using 0 indexing. So in other words, 0 corresponding to 1, and n minus 1 will corresponding to n. So this is the convention, right? So originally the ball is at the first person. So here I'm going to set d0 equals 1, right? So this setting or this convention of indexing is better tailored for modulo n operation. And then we're going to encode the rule because in general for ith turn, so the steps away should be I times k. So I'm going to set 2 variables, current round and current position. So the current round will be 1 and the current position is 1. So here I'm using 0 indexing, where it will be 0, right? So we just need to pay attention to the return format using this convention. And then we're going to write a while loop. So while true, because this way of writing, I'm going to use break keywords in between. So basically, we are incorporating this logic. The game is finished when some friend receives the ball for the second time. So you can interpret the values in the dictionary for corresponding times of receiving the ball, right? So now we are ready to do the logic or simulation. So at the current round, we are in the current position. So the next position will be the current position plus the round number, current round, times k, right? Then we need to do modulation. So we are going to modulo this by n. So the next step will have a range from 0 up to n-1. So the inconsistency with this dictionary setting. So next, we are going to set the next position. So we increment the number of times it receives the ball by 1, right? Now we are going to do a check. If the next position, so if this person or this position receives two times the ball, so we're going to break, right? Otherwise, so we're going to increment the current round by 1. So that way, next time we're going to compute the correct round times k, right? Steps away. Also, we need to update the position. The current position will be our next position, right? So this way, we finished the main logic. So this is the update, and this is the stop condition, right? So afterwards, what we're going to do is to return the persons who haven't received the ball after the game stops. So basically, we can use list comprehension. So here, basically, we return I, but I is the k for the dictionary. It's in between 0 and n-1. But here, we're using one indexing, so I'm going to return I plus 1. So here, for I and v in d items, if the d equals 0, in other words, this person does not receive ball actually during the process. So this way, we finished the coding for this problem. Before we make any comments, let's first do a check. This is not right. Let's see. Here we have di because I in the range n. So d0, so current round 1 0, and then current position plus current round times k, then modulo n. So then we increment this next position by 1, and then if this is a 2, so we're going to break, and then current round incremented by 1. So here, I guess the reason it's not right is like this. So let me write the correct return. So here is I plus 1 for I in range n, right? If di equals 0. So this way, because we need to return the losers of the game in ascending order. Now let's check again. Yeah, we have the right return for the first example. Now let's also test the second one. That is 4 4, right? So now let's see. Yeah, we get the correct answer. So now let's look at the generic case. Yeah, it passes all the cases. I guess as for coding, that's about it for this specific problem. So this problem is marked as easy by leetcode. Actually, the logic is indeed easy. However, when we are dealing with the indexing, so sometimes it can be tricky. So it's good to do such practices. So with that said, I guess that's about it for this specific video. So if you like, it's actually rewarding to try to think up other ways to address this problem or simplify the code format here. With that said, that's it. Thank you.